Hi, hello everyone. Thank you for coming to this session. And today I will talk about how to create multiprocess server on Windows with Ruby. And I will show you basic knowledge and functional Ruby function for Windows programming. Before starting presentation, let me introduce myself. My name is Ritta Narita, and I graduated university last September. And after that, I enrolled in Treasure Data. Treasure Data is data management platform service, and you can easily store data and manage them. Let me introduce about Treasure Data service architecture a little bit. Using Treasure Data, you can easily store your data into Treasure Data, and you can easily analyze the data on them. When you want to store log data in real time, for example, weblog on your server or sensor data for IoT, you can import data using Treasure Agent. And when you already have large data on your storage or database, you can execute parallel upload using bulk import. After you import data, you can query the data with SQL or some API. And also, you can output the data to other storage or database like Amazon S3 or MySQL or others. And for importing streaming data, we are using open source software Fluently for solution. Fluently is a data collector for streaming data. Using this Fluently, you can easily collect streaming data, and after filtering, buffering, or routing, you can output it wherever you want. In Fluently, you can set input plugin and output plugin. And with these plugins, you can connect the source of data and the space you want to output. For example, you want to store the data access log on your server into MySQL. You can do using in-HTTP plugin and output MySQL plugin. In this way, you can customize a way to collect the data for your environment. Let me show you one example. When you want to input HTTP request for port 8000 and output this log to console, you can use in-HTTP plugin and out-stdout plugin. To use this plugin, you need to write plugin like this, write plugin type, and write port number or byte number. In this case, for in-HTTP plugin, you need to write HTTP as type and port number 8000. And others in Fluently config file. And then for output stdout plugin, you only have to write match pattern and stdout as pattern as type. By doing only this, you can get this log data. Let me show about demos about that. After executing Fluently with Fluent config, you can send post with JSON, and you can output to the console. And as I said before, you can set the plugins in Fluently conf. And let me show one more example. And in Fluently, there is a command FluentCut. And this is the tool to send JSON to the port with TCP. And if you want to FluentCut, yeah, you can use in-forward plugin and set forward as a type, and same as in HTTP plugin, and as same as out stdout plugin, you can set like this. Let me show demos. And same as before, previous one. You can, after executing the code, you can send JSON with fluent cut, and you can output to the console. And as I said before, you can set like this. This is Fluently. As base engine, Fluently uses Serverengine. Serverengine is multiprocess server framework, and this is also open source software, so you can also check it on GitHub. And let me introduce about what Serverengine. Serverengine is a framework to implement robust multiprocess server, and this is like Unicorn. As well as Unicorn, you can daemonize under supervisor and create some workers under server. And each of them are connected with Heartbeat via pipe. And if there is something wrong with workers and it stops, it can restart automatically. And you can configure with running supervisor or server, and it can do live restart. With this Serverengine, you can implement robust multiprocess server very easily. Let me show one function of Serverengine, auto restart. If worker died unexpectedly, it's detected by Heartbeat and server launch worker again. Let me show the demo about auto restart. After executing Fluently, there is a process under supervisor, and after killing this process, the process restarts automatically and new process generates. This is auto restart function. And in Windows, you can use auto restart as same as in Unix. After executing Fluently, there is a process under supervisor, and killing this process with task kill. And you can use Fluently as previous one. You can output log to console. This is Serverengine. It is very easy to use Serverengine. And it's almost same as Unicorn, so if you have tried to use Unicorn, you can use Serverengine very easily. Firstly, you need to write server module and worker module. In server module, you need to write what you want to do before launching worker or after launching as usual server framework. In this case, if you want to pass the TCP socket to the worker, you need to create socket here. And in worker module, you need to write some process in each method like run or stop. If you want to write accepting socket in each worker, write it in run function. After that, you need to write configuration for Serverengine. For example, create daemon or not, log file path, PID path, worker type, or the number of workers. After writing config, you can just run. That's all. By doing like this, you can run robust multiprocess worker very easily. As worker type, you can choose from 3 worker types: thread, process, spawn. When you want to use thread as worker type, you need to write thread for worker type in Serverengine config. Or you want to use process as worker type, just write process. And if you want to use spawn as worker type, just write spawn for worker type and give the command you want to run for worker. This spawn type is used in frequently. When you want to use frequently in multiprocess, now without Serverengine, you have to use in multiprocess plugin and write each command for each worker. Then, if you want listening socket for each worker, you have to use different port number. It is broad and inconvenient. But by introducing Serverengine, you can share one socket with each worker from parent process. By socket manager, you can use much core power for TCP requests without any assignment, just by dividing some worker. This Serverengine is so-called prefix server, but this is different from prefix server like Unicom or Nginx. Then what's the difference of them? As ordinary prefix model like Unicom or Nginx, server only have to share a socket when it forks. That's because server can know which port should be opened before forking. Then it only have to create listening socket in server and just send this to worker. This is very simple. But in Serverengine, it's assuming that you can know which port after forking. For example, if infrequently, port information is written in config file, and the worker passes this config in worker itself after fork. That's why we should assume to know which port after fork. Then Serverengine prefix model is like this. After server forks worker has to send requests from worker firstly. And as a response, server sends socket to worker. Unlike as a prefix server, worker should send requests. Then I will introduce about how to create multiprocess server for Windows with Ruby step by step. I will introduce niche and useful Ruby function and the tips to develop for Windows. Firstly, to create worker, how can I do that? In Unix, there is fork function. Then we used fork to create worker. But there is no fork function in Windows. Then I use spawn. Spawn is a famous function, so I guess many people know this. But spawn executes specified command, and for other process, and you can get process ID. Using this process ID, server manages worker. This is same as creating daemon. When demonizing is in Serverengine, it spawns with past command parameter. And then in application side, it passes the command to execute file to demonize. In Serverengine, there is a function to demonize server. So in the file, write code to run this demonizing method. Like this, we should use spawn for creating demo or worker. After creating worker like this, how can I deal with socket requests from worker? In Unix, it's not difficult to share socket, but there is a problem about file descriptor in Windows. In Unix, parent process can share file descriptor with child process. Then to share socket, you only have to share file descriptor when creating child process. Or after created, you can send it with Unix domain socket. But in Windows, you can't share file descriptor because file descriptor in Windows is just concept function of compatibility for Unix, and file descriptor in each process is independent. Then you cannot share file descriptor in Windows. Then how do you send the socket in Windows? The answer is using Windows API WSS duplicate socket. By using this API, you can duplicate socket. What to pay attention to use this API? is that this API needs to assign process ID, and the duplicate socket works only in the assigned socket. For example, when server PID is 1000 and worker's PID is 2000, firstly, you have to duplicate socket assigned to PID 2000 and pass the protocol information for the process of PID 2000. However, this API is prepared only for C. Then you can't call from Ruby directly. And I want to say that almost all of Windows API is only for C. So to develop in Windows, it's very important to call API from other language, here from Ruby. Then how do you call this API from Ruby? The most general way is to use C extension. And maybe, I guess many people have used this way. You can call C method in Ruby very easily. But in this Serverengine case, there is no C extension code, and all of them is written in Ruby. So if possible, I want to write with only Ruby without C extension. And second solution is using FFI. FFI stands for Foreign Function Interface, and you can call method from shared library like DLL or SOFI. How to use FFI in this case is like here. You can define type with typediff, and you can close shared library with FFI lib, and you can define struct also. Here defines protocol information. And to define function, you can use attach function, like this. And here, in this case, attach function WS duplicate socket, here. Like this, you can define the function to duplicate socket. When you use this method, you can create struct with new, like this. And you can just call the method and set the struct pointer for argument for this method. But this FFI will include gem dependency. So I want to find the other way to reduce dependency as possible. Then I used fiddle as third function. Fiddle is also the library to deal with shared library. But this fiddle is built-in library, then you can call without any gem dependency. It's safer than using FFI gem. How to use fiddle is right here. To define function, call extern function, like this, and write down like C sentence. Then you can call this method, like this. And by setting the pointer of protocol information, you can get protocol information of the duplicate socket here. And to create this pointer, you have to create struct. You can do it with malloc function. In fiddle, you can use struct in almost same way as C. You can get struct pointer by calling malloc. This is very functional. With this WS duplicate socket and fiddle, you can duplicate socket. Then you have to share information of socket protocol. You can send protocol information by converting protocol to binary. And you can send this binary to you have to change it back to protocol. There are some functions to convert binary to struct in fiddle. Then you can get protocol information like this. After you pass the protocol information to worker, you need to create socket from this information. To get socket from protocol, you have to call a method to create socket, WSA socket. You can call this using fiddle like before. You can set protocol and you can get socket. But this socket is handle. Handle is like file descriptor, but you can't duplicate handle like file descriptor. And this handle is C-layer socket. We can't use TCP server class in Ruby. This is very inconvenient because you have to use FFI or fiddle for everything. For example, you have to use WSS send for write function in TCP server class, or have to use WSL receive for read in TCP server class. I want to deal with this socket in Ruby layer. Then I use the function to wrap handle with file descriptor. It can convert handle to file descriptor. This function wrap function open OSF handle, which can assign file descriptor and create I/O object. By this method, you can get file descriptor. You can create TCP server class by this. This can be also called by fiddle. This function is in Ruby DLL. Then you need to load from install Ruby path like this. After loading DLL, you can call this method like before I explained. Now you can deal with socket in Ruby layer, and you can create TCP server class socket from file descriptor. And to send this request or response, how can I do that? At first prompt, I use DRB because there is no Unix domain socket in Windows, and there is no stable way to use named pipe in Windows in Ruby. Then I use DRB and worker calls server function via DRB and create socket and return socket to worker. But this has race condition problem. For example, firstly, worker A calls function to send socket. Then server creates socket for worker A and calls send IO in DRB. After an interval, worker B calls the function and send IO like before. After that, the worker B calls receive IO before worker A, and it receives socket for worker A by mistake. And after that, worker A calls receive IO and receives socket for worker B. It calls function in order with interval. Then the problem like this doesn't happen so much, but its impact is significant if it happens. Then I improved the model to use Unix domain socket or TCP server. Server creates several Unix domain sockets for each worker. After worker send requests, server creates socket for these requests and return socket as a response. There is no Unix domain socket in Windows. Then I use TCP server instead. But we need port number for this TCP server. Then we need to find unused port using netstat. This is not smart code, actually. Then I want to use method. I want to use named pipe in Ruby. Then you can share socket with worker. It can listen with multiple worker. Then how do you deal with HTTP requests? Read non-block is useful for server, but there is no read non-block in Windows. Then I use read partial instead. The difference between read non-block and read partial is like here. Read non-block is called with non-block. Then, if there is no data, it raises an exception. Against that, read partial is called with no block. Then it blocks if there is no data. The difference is only this, then we need to write with care of this non-block difference. And then difference between normal read and read partial is like here. Normal read is for less than 2048 bytes, and against that, read partial can set how many bytes it reads. And in normal read, it returns new if it's end of file. In read partial, it raises an exception. Then read partial is more flexible than normal read when writing server, so we can make use of it. And I want to discuss about if there is not sendering head problem or not on Windows. As you know, sendering head is a problem that from one request, multiple socket is accepted. In Unix, the kernel takes measure about this, then it doesn't occur. But I didn't know if it does on Windows or not when I implement it. As a result of benchmark test, I found that sendering head doesn't occur in Windows, but I implemented accept mutex for the first idea. So I show you the accept mutex. When worker starts, only one worker will get mutex and attach listening socket to the event loop. After this socket is accepted, before dealing with data, release mutex and that socket from event loop. While the worker is dealing with data, the worker will listen and accept. By this, we can save time to deal with data, and it can deal with many requests. This is my accept mutex plan. And I implemented accept mutex to rotate worker in order. Then, like this result, you can see that accepting in the process is rotated in order and in same order. Of course, this is not perfect implementation, and you can write better one using IOCP. IOCP is the Windows API to deal with multiple requests, and this is like select or epoll in Unix. Using this IOCP, you can implement asynchronous I/O in Windows. To use IOCP, firstly, you need to create completion pod and attach threads to this. In each thread, you need to attach socket I/O. And after that, completion pod will manage these threads, and one socket is listened while other worker is queued. After one worker accepts, it will call get queued completion status, and this thread will be queued, and other thread will be waiting. And this worker can listen. I don't know what's the efficient way to use IOCP, but I guess two ways to implement IOCP. One is creating IOCP in server process and attach socket in completion pod. And after that, duplicate socket and of this and share the information and create socket from information and attach this also to IOCP. Or in each worker, create completion pod and attach in worker. This is the demo of listening in multiprocess in fluently. After executing fluently, you can see the 4 workers on the supervisor. And after sending Fluent code, there's a PRE in left side, and PRE is different in each result. This is the result of listening in multiprocess worker. And rough result of benchmark is right here. I use Fluently, and as plugin, I use in HTTP and output forward plugin. I used 4 processes for workers, and the result shows it got about 2 times faster. It is natural to be able to make it faster, but I think we can improve better and faster. I don't know the bottleneck still, but we can improve with IOCP or some other way in Fluently. So I want to summarize the conclusion. To develop in Windows, you need to care about some programs using Windows API. And Ruby has very helpful and niche function to deal with difference between OS. So Ruby is great language. So thank you for listening.